Image resolution is a concept that frequently confuses newcomers to digital imaging because, as we shall see, high-resolution and low-resolution images often look the same on screen. But it is really important to understand that what looks the same really isn't the same. Unless you appreciate the differences, you'll become very frustrated very rapidly in terms of accomplishing what you'd like to do with your images. So we're going to try to lift the veil of complexity from this issue in just a few minutes of basic explanation. Much of the confusion stems from the advertising and media hype surrounding the number of megapixels a particular camera offers. This was a very important consideration in the early days, and by early days I mean way back in 2005 or so. But over time, most cameras in use today have reached the 6 or 7 megapixel level. And the truth is that while the number of pixels is important, beyond this level, everything is overkill for about 95% of typical users. Please don't tell the camera manufacturers on me, but I'm not the only one. This article, by David Pogue, the technology editor for the New York Times, is one of many that try to explode this misconception. So if the sheer number of pixels is not the only important consideration, what is it that determines whether an image is considered to be high or low resolution, and what difference does it make anyway? The answer is that in addition to the number of pixels, the density of those pixels, or how closely packed together they are, is critically important. There are really only 2 levels of pixel density that we need to be concerned with. The first is 72 ppi, or pixels per inch. It turns out that the overwhelming majority of computer monitors and displays are only capable of displaying 72 pixels per square inch of surface. This means that even if you had a 1 trillion megapixel image, it wouldn't look any better on screen because the display is only able to show you 72 at a time. I should mention that there are some monitors that display at 96 ppi, but for our purposes that's pretty much the same thing. To make prints, however, we need 300 ppi. And that's true whether you're printing at home on your inkjet printer, taking images to the local Walmart or CVS, or uploading files to an online photo finisher. Printer resolution is sometimes expressed in terms of DPI, or dots per inch, which refers to the number of ink droplets deposited on the paper. Although DPI and PPI are technically different things, they function in much the same way, so we can use those terms interchangeably. It's also true that some printers operate at 200 dpi, some at 240. But the bottom line is you need a much higher concentration or density of pixels to make a print on a piece of paper than you do to view the same image on a screen. This slide illustrates the difference, I hope. Assuming that the area of both gray squares is the same, 1 square inch, a low-resolution file like the one on the left will have fewer pixels within that space, and there will be greater distances in between them. The image on the right, the high-res file, will have many more pixels packed into the same physical area, resulting, obviously, in less space in between them. Why is this important? Well, anywhere there's dead space between the pixels, the software has to guess as to what belongs there. That's called software interpolation. And while there are admittedly some seriously brilliant minds hard at work on this issue, the sad truth is that as of this moment, the software does a pretty poor job at trying to figure out what belongs in the dead spaces. The result is that if you try to make a print from a low-resolution file, you'll invariably wind up with a mushy, inferior result, even though that image may look just dandy on your computer screen. You might wonder what this image is about, but I think it serves a quite useful purpose. If I were a pixel instead of a person, and I were living inside a high-resolution image file, this is what my life would be like. There would be many, many of me, and we would all be packed as tightly as possible into this confined space with very little empty space in between us. The interesting thing about this is that we can always bring this train into the station. We can open the doors and let some pixels out. In other words, we can always convert this high-resolution file to a low-resolution file by discarding some of the pixels. We can thus create both a high-res and a low-res version of the same picture and use the appropriate version when we want to make prints or send an image via email or post it to a website or whatever. At the other end of the spectrum, if I were a pixel instead of a person living in a low-resolution image file, this is more what my life would be like. On the surface, it looks a lot nicer than being on the subway. But the truth is, those big, giant spaces between the pixels become a real problem. And unlike the packed subway car that can always let some pixels out, there really is no way to add new pixels to a low-res file. This is not some popular beach resort in the summertime. If you were to arrive on a sunny summer morning, say at 7 or 8 a.m., this is in fact what the beach might look like. Not too many pixels, lots of space in between them.